Okay, everybody, 2.8, the last section in this chapter, graphing inequalities, both linear and absolute value. So very similar to graphing the regular equations, but the inequality is going to give us just a little bit extra to do. So quick review, let's graph 2x plus 3y equals 6. Since this is in standard form, I'm going to graph this using my intercepts. Remember my x-intercept, I know y is equal to 0. So that takes the y part out. So 2x equals 6, so x equals 3. So my x-intercept then is 3 comma 0. To find the y-intercept, I know my x is equal to 0. So that takes the x part out. 3y equals 6, so y equals 2. My y-intercept then is 0 comma 2. So if we graph those, here's 3, 0, here's 0, 2. There is my line when I see those dots. Let's see, let's put the ruler on here. Love the ruler. Whoever reminded me of the ruler, thank you very much. And put some arrows on the end because it's a line. Goes on forever in both directions. One of your geometry things. So there's a graph of our line. What's the slope of this line? Well, since I have the ordered pairs, I'm going to count. I'm going to count from this green one here up 2. So I'm going to rise 2, and I'm going to run 1, 2, 3, but to the left, so my slope is negative 2/3. Does it make sense that my slope is negative? It does. So what happens when we change it to an inequality? So instead of equaling 6, now I am greater than or equal to 6. So the line, the equal to part, will stay exactly the same. The difference will be the greater than. The greater than involves shading. So one thing that's going to be different is we have to decide where to shade. The second thing is we will have to decide solid or dashed for the line. If it's equal to, will be solid. If it's not equal to, will be dashed. And the reason we dash it is because put a bunch of open circles there to say I'm getting really close but not touching, how we use open circles on our number lines. It's really annoying to graph that. So we just do dashes to make it easier and a little quicker. So how do we decide where to shade? I usually pick a test point. You pick a point that you know for sure which side of the line it falls on. The easiest test point to plug in is 0, 0. So I usually pick 0, 0. When I plug in 0, 0 into my inequality, I get 2 times 0 plus 3 times 0 is greater than or equal to 6. That says 0 is greater than or equal to 6. Is that a true or a false statement? That is a false statement. So I want to shade, because it was false, where the test point isn't. So 0, 0 is here, the orange, that's my test point. That's a false statement that says 0, 0 does not work in the inequality. So then I would shade on the other side of the line. If my test point is true, meaning it works, then I want to shade on the same side as the test point. And you can pick whatever point you want for your test point. You just need to make sure you know which side of the line it falls on. So let's look at an example here. This one is in slope-intercept form. So I'm going to graph it a little differently. What's the slope of this line? Remember, the slope is the coefficient on the x. So my slope is a negative 2. How about the y-intercept? The y-intercept will be 0 comma b. Remember, the b is the plus or minus number at the end. So in this case, it's a 1. So I'm going to plot my point 0, 1. My slope is negative 2. So I'm going to go down 2, 1, 2 to the right 1. Down 2, 1, 2 to the right 1. Now, before I graph anything, I need to ask myself the question, solid or dashed? Because my inequality is not equal to, I'm going to have a bunch of open circles. So the open circles because it's not equal to, is going to make the line dashed. So when I dash this, or when I draw on this line, I'm going to dash it. So put arrows on the end because it's still a line. That says I'm going to get all the way up to it, but I'm not going to include any points on the line. Where's my test point? Well, I know where 0, 0 is going to fall, so I'm going to choose 0, 0. When I plug in 0, I get 0 is less than negative 2 times 0 plus 1. That says 0 is less than 1. Is that a true or a false statement? That is a true statement. So that says I want to shade where my test point 0, 0 is. So I'll shade on this side of the line. The only other thing I have to answer is what's the x-intercept? We know the x-intercept, y is equal to 0. So we'll have 0 equals negative 2x plus 1. Subtract 1 from both sides. Divide both sides by a negative 2. X equals 1/2. So 1/2 comma 0. Ooh, that's pretty good on my graph. Look at that. That looks like a 1/2 comma 0. Whoop, whoop. Doing good. So it's about solid or dashed, and then shading. That's the extra layer that the inequalities have. All right, so now we've done some absolute value graphs. Spent a couple days on that. So let's do an absolute value inequality. So first thing, solid or dashed. So again, I'm going to look at the inequality. Is that going to be solid or dashed? Since it's not equal to, it will be a dashed graph. How does this absolute value open? Well, since my outside the front there, my leading coefficient is a positive 1, it opens up towards the positive. So in my brain, I'm thinking, okay, I've got an upward facing V. Remember, absolute values, V, vertex. All right. So where is the vertex? That says, where does inside the absolute value equal 0? Where does 2x plus 1 equal 0? It equals 0 at negative 1/2, comma, peel off that back number, the negative 3. So my vertex is at negative 1/2, negative 3. And what about the width? Well, let's see. I'm going to plug in something like 0 and get an idea. If I plug in 0, 2 times 0 is 0, plus 1 is 1, absolute value of 1 is 1, minus 3 is negative 2. So 0 is here at negative 2. But remember, because of the symmetry, negative 1 will also be at negative 2. Pick another point. Let's plug in 2. So we'll have 2 times 2 plus 1, absolute value of that, minus 3. That's 5, minus 3 is 2. So 2 is here at 2. So then that makes negative 3 also at 2. Can we see the V forming? We should be able to. So then when we go to graph this, we're going to dash it. We already decided that because it's not equal to. I could have used the ruler, just decided to freehand this one. The width, what does that look like? Does that look like up 1 over 1, up 1 over 1? No, it's a little bit narrower. And that has to do with the B and the C in there. And a test point. So where's a point that I know for sure where it falls? I know where 0, 0 falls. So I'm going to plug in 0, 0. So that's going to say 0 is greater than absolute value 2 times 0 plus 1 minus 3. 0 greater than absolute value of 1 minus 3. 0 greater than 1 minus 3. 0 greater than negative 2. True or false? Do, 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 do. True or false? That is a true statement. So I want to shade where 0, 0 is. 0, 0 was here on the inside of my absolute value. So I'm going to shade on the inside of the V. The two sides of an absolute value graph are either inside the V or outside the V. In this case, we were inside the V. Let's try 3. What's the vertex? Where does it open? Solid or dashed? Where do you want to start? I'm going to start with solid or dash. This one's going to be solid because it's equal to. Opens, because of that negative out front, it opens down. So in my head, I got a downward V. The vertex on this one is pretty easy. What makes inside there equal to 0? 7, comma, peel off the back number 2. So we were at 7, comma, 2. I'm opening down. What's my slope? I don't have a B. I don't have an A. So my width is going to be regular. My slope is going to be 1 and negative 1. So plot a few of those points. I'm going to connect it with a solid line. I already decided that. So I'm going to pick a test point. I'm going to choose 0, 0. 0 greater than or equal to negative absolute value of 0 minus 7 plus 2. That's a 0 greater than or equal to negative absolute value of negative 7 plus 2. That says 0 greater than or equal to negative 7 plus 2, 0 greater than or equal to negative 5. True or false? Is 0 greater than negative 5? That is a true statement. So here's where my 0, 0 test point was. So I want to shade where that is, which is outside the absolute value. Outside the V. Now I could, extend my line down. Extend my line down. It doesn't stop on the grid, right? Because the grid keeps going. It's just, take up way too much room if I had it going forever. So again, on the absolute value, you're either inside the V or outside the V. Here's a case where we were outside the V. Oh my God, I got one more. Vertex. Vertex is going to be at 0, negative 5. This opens, what do you think? What do you think? Down, good, because of the negative. Solid or dashed, it's not equal to, so it will be dashed. The width, it's a little tricky because of the 1/3. The 1/3 is going to shrink it horizontally, so it's going to smush it together, and it should look a little more narrow. Let's check it out. So my vertex is at 0, comma, negative 5. I know I'm opening down. Let's plug in another point. Let's plug in negative 3. So if I plug in negative 3, that gives me the absolute value of negative 1 minus 5, and there's a negative out front. That gives me negative 1 minus 5, which is negative 6. So through negative 3 is at negative 6. Sorry, I said narrower, should be wider. Because the 1/3 is going to stretch it horizontally, not shrink it horizontally. I had that backwards. Sorry about that. So then 3 will also be at negative 6. This was dashed. Dashed. Pick a test point. I'm going to go 0, 0. So sorry, the width is wider than normal. Is the 1/3 inside the grouping, opposite of what you expect. So it's going to basically multiply things by 3. So that's going to stretch it horizontally by 3, which will then make it wider. Test point 0, 0. So it's out here. 0 less than negative absolute value 1/3 times 0 minus 5. 0 less than negative, this is here is 0. So the absolute value of 0 minus 5. Absolute value of 0 is 0 times the negative 1 is 0. So this says 0 is less than negative 5. That is a good false statement. So I don't want to shade where 0, 0 is. So I want to shade where 0, 0 isn't, which is going to be inside the V. Little hint on absolute values. If it's less than, you'll shade below, which in this case is inside. If it is greater than, like number 3, you will shade above, which in this case happens to be outside. All right, thanks everybody. Bye.